Okay, so today in second and third periods, we got a little interrupted. Lockdown, fire drill, all kinds of fun. So this is fifth period, and I'm going to let them say hi.
Hi.
And we are now looking at two-way tables, which is something we often look at in probability just because it's a way to organize information, data, information that we can quantitatively or quantify, I guess is a better way to put that. And very often we read two-way tables when we're looking at probability or trying to organize our data. So a two-way table, useful way to organize data that can be categorized by two variables. So suppose you ask 20 children and adults whether they liked broccoli. Okay, the table to the right shows one way to arrange that data. So our two variables basically are whether the person is a child or an adult and whether the person does or does not like broccoli. And so they've organized that into a table. Okay, within this, we tend to pay most attention to relative frequencies. Technically, there is joint frequency, marginal frequency, and, well, basically just joint and marginal frequency. And if you look at a table like this one, the joint frequencies, well, let me just actually find a better one. The joint frequencies basically are just your individual 3 children like broccoli, or 2 adults don't like broccoli. And marginal is basically, kind of think about it's in the margins, it's along the sides. Okay, that's when we add these things here along the sides. Most of the time what we look at is not just the frequency, which frequency is just a count. I just counted up like on this table right here. So this is just, these are just a count. It says 3 children do like broccoli, 8 children don't. 7 adults do like broccoli, 2 adults don't. But when we say relative frequencies, and all of these say relative here, relative means I'm dividing. It's more like I'm looking at the probability. I'm dividing by how many adults there are, or how many children there are, or how many people there are, depending on what I'm going to be asked. So joint relative frequencies are the values in each category, like children who do like broccoli, divided by the total number of values. Okay? And they're giving us the space to write something like this: joint frequency divided by total number. So a joint frequency is just those numbers. So 3 is a joint frequency, 8 is a joint frequency, etc. Divide those by your total numbers and you have some values. The values are right here. They're always, the joint relative frequencies are the values sort of in the main area of your table. So in other words, how many people are talked about up here total? 20 people. Okay, so for instance, children who like broccoli. Children who like broccoli are 3 out of 20. 3 children like broccoli, 20 people total. 3 out of 20 is 0.15. Okay, so that's where that 0.15 came from. And here under no children, no, that means 0.4 is what I get when I divide the 8 children who don't like broccoli by the total. So 8 out of 20, excuse me, is my total number of, or excuse me, is my joint relative frequency of children who don't like broccoli. So that means it's relative to the total, and it's from the joint frequency, which means the main kind of categories. So 8 over 20 comes to 0.4. This 0.35 comes from doing 7 over 20, and the 0.1 comes from doing 2 over 20. So all of these numbers right here that I just circled, those are your joint relative frequencies. Okay, and that's where they show up in the tables. Marginal relative frequency is, again, the margins of your paper or the sides of your paper. So it's kind of the same idea, sides of the table. Marginal relative frequencies are found by, how do you think I'm getting the 0.55 here from 0.15 and 0.4? Adding the joint relative frequencies that we just found here in each row and column. So I circled in this table, I circled joint relative frequencies. I'm going to say circle joint relative frequency. I'm going to box my marginal relative frequencies. So this is a marginal relative frequency. This is a marginal relative frequency. The bottom of each column is a marginal relative frequency. So the end of each row and the bottom of each column. And this should always be a 1 because this is talking about relative frequencies. In other words, this is the relative frequency of children in my sample, and this is the relative frequency of adults. In other words, altogether 0.55 out of 1, or 55% of the people who answered are children, and 45% of the people who answered are adults. So that should add up to 1 because altogether everybody in my sample is either a child or an adult. Same thing here. It's a yes or no question, so everybody in my sample should have either answered yes or no. So 0.5 plus 0.5 should add up to 1. Okay, so this corner will always be 1. Conditional relative frequency. Conditional is where I narrow it down to just part of the groups. So you're dividing a joint relative frequency, the circled number, by a marginal frequency. So if I divided, for instance, this 0.15 by 0.55, I would be finding out what percent of children said yes. Not what percent of everybody. This is the percent of everybody that was a child who said yes. Down here, this is the percentage of everybody, just period, who said yes, children or adults. But if I want to know what percent of the children said something, that means I go to the end of the children's row, and that's the bottom number now. Or if I said what percent of the people who like broccoli are adults, what percent of the people who like broccoli means my total is now just the people in this column, the yes column. So my bottom number is 0.5. So I'm dividing a joint relative frequency, one of the circled numbers, by a marginal relative frequency. It should say marginal relative frequency. Relative frequency. And conditional relative frequencies can be used to find conditional probabilities. So example 1. The table shows the results of randomly selected car insurance quotes for 125 cars made by an insurance company in 1 week. Make a table of the joint and marginal relative frequencies. So in other words, anytime the word relative is involved, that's when I'm dividing. So teens with 0 accidents. First thing is, what is my total here? What's the total for example 1? 125. Like the total number of items talked about in my table are 125 because I said that right up here. So for teens with 0 accidents, I'm going to take 15 and divide it by 125 and get 0.12. So again, since these are relative frequencies, anytime it asks you for a relative frequency, that means you're dividing. So it's going to be a number smaller than 1. It's going to be point something. Okay? Adults, 53 out of 125 gives me 0.424. 1 accident teens, that's 4 out of 125. 0.032. 1 accident adults, 32 out of 125 is 0.256. Teens with 2 or more accidents, 9 out of 125, 0.072. And adults with 2 or more accidents is 12 out of 125, or 0.096. Those are my joint relative frequencies. So the joint relative frequencies are right here where my categories join each other, basically teens versus the number of accidents and adults versus the number of accidents. Now at the bottom of this where I'm totaling my column, or at the side where I'm totaling my row, what are those called? Yeah, those are your marginal relative frequencies. So basically now I'm just adding up. This is what I get here. Let me point something out here, is that I can get to 0.224 by adding up this column. I could also, though, I could get it by adding up the number of teens and dividing by 125. It's going to give me the same thing. Okay? So go ahead and add up the adult percentages, or decimals. Looking at those two numbers, how do I know that I did it right?
They add up to 1.
Perfect. They add up to 1. Going across, they should add up to 1. And the same thing when I get these numbers. So go ahead and fill in these numbers. So you can check yourself because these should add to 1 and these should add to 1. Okay, so let me just see if I can color coordinate this somehow. These numbers here and these numbers here are my marginal relative frequencies. The ones I just boxed in green, if you can see the green. And these that I'm shading are my whats? Joint relative frequencies. So the vocab is important here because you have to know what you're being asked for. If you don't know what they're asking for, you can't do it. But the process is pretty easy. Okay? Looking down here at example 2, a reporter asked 150 voters if they plan to vote in favor of a new library and a new arena. The table shows the results. Okay, so first we're going to go ahead and quickly make our table of joint and marginal relative frequencies. It's 150 voters total, so that's what I'm dividing by each time. Helpful hint. To speed up the process, you can do several at once. And I'm not pressing enter on my last one because when I do, I have a feeling it's going to go, the top one's going to go away. Nope, I've got all of them. Okay, so you guys are finishing up that. And this B part is why I went ahead and wanted to do this example 2, because they're almost the same thing as what we just did in example 1. But I wanted you to look at the wording. So if you're looking at the wording right here, if you are given that a voter plans to vote no, anytime you're told that if you are given something, that means you're narrowing it down to just that row or just that column. Okay, that's what we call a conditional probability. We're being told, given that this is true, meaning only out of this group. So given that I already know it's a voter who plans to vote no. Basically, as soon as I read that, given that it's a voter that plans to vote no to the new library, it's almost like in terms of my chart, now suddenly I can only see this column. Because that's the only column that matters now. When they say, given that it's a voter that plans to vote no. Okay, so if you're given that a voter plans to vote no to the new library, what is the probability that they also plan to say no to the new arena? So they're saying out of just this data, what is the probability that they're going to say no to the new arena, which is the second row down? So just this data, we're going to say the 0.28 out of the 0.48. We have to divide by the total for just these people. So it's 0.28, the no's to the arenas in that column, out of that total column. So 0.28 out of 0.48. So the second they say given a voter plans to do blah, 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 or given a person hates broccoli, or given a person is a child, that means you're narrowing it down to only that row or only that column, which means your bottom number in your probability problem is going to be the total for just that row or just that column. In other words, your bottom number is going to be a marginal relative frequency. So 0.28 divided by 0.48 gives me 0.5833, and I'm going to say that. That's the probability that the person is going to also say no to the new arena. Okay, so it's very important to understand that's what you're being told to do when you say, given that. They're saying, let's narrow it down to just one row or just one column and pick whatever you have to pick out of that column, but then your bottom number is just going to be the total for that row or the total for that column. Questions on that? I think a lot of you guys are going ahead and doing other problems, am I right? Yeah, okay. These are pretty fun, that's fine. I'm not criticizing. Nope. Okay. No questions on this?